right, today we are starting chapter 8, and what we have on the screen here is probably familiar to you. You've probably seen square roots before now, but we're going to take it to a different level today, of course, now that we're in high school. So if I asked you what was the square root of 49, I imagine most of you would say 7, because 7 times 7 is 49. And if you remember, we use the word square when we multiply a number times itself. So like this right here, we would say is 5 squared. 5 squared means 5 times 5, or 25. Oop, that was our next example. And so the square root refers to what number times itself equals the number inside. And so it's the square root. The root is this. That's the root of what's being squared. And so we are looking for what number times itself equals the number inside the square root. And so as I just illustrated here, that would be 5, because 5 times 5 is 25, and the square root of 25 is 5. Now this next one, most of you probably know that's 4 times 4. But remember, when we have a negative in front, that stays in front, okay? And so that answer is going to be -4. Notice, though, we don't have this problem here. So this one here is no solution, because there is no number times itself that will be negative. So this one's okay because the negative's in front, but the negative inside, that's no good. So you won't see that one. We know that's 3 times 3, so that's 3. Now these next problems here, there's a number in front, and we're still simplifying the square root. So for example, this one here, we already know this is 4 times 4. And so this is going to be, this 2 is still in front. It's kind of like when it's 2 square root of 16, it's like 2 times the square root of 16. When things are next to each other, it means multiplication. So this is going to turn into 2 times 4, because 4 is the square root of 16. And our final answer, 8. Now this next one, it's hard to see. There is a little negative sign there. So this is going to be, this one we learned up above, that's 7, right? So this is going to turn into -3 times 7, or -21. And finally, this last one, 81, is 9 times 9. And so 5 times 9, or 45, is the answer to that one. Now, something we didn't do yet, which is a good idea, is to make a list of all the perfect squares. So 1 times 1 is 1, 2 times 2 is 4, 3 times, we'll do little squares there, 3 times 3 is 9, 4 times 4 is 16, 5 times 5 is 25, 6 times 6 is 36, 7 times 7 is 49, 8 times 8 is 64, oop, that's supposed to be 9. 9 times 9 is 81, 10 times 10 is 100, and then you should learn through 12 at least, 121, 144. So you should be on the lookout for those perfect squares, especially for these early problems. But now we are getting into something else. In other words, what is the square root of 45? Well, 45 is not a perfect square. We just got done listing them all, right? But there is a perfect square factor in there. So what we want to do for problems like this, when it's not a perfect square, is we're going to break it up into its prime factorization. So we know this is 5 times 9, and 9 is 3 times 3. So this is what we call factor tree. And it can't be broken down anymore. 5 and 3 are prime numbers. But notice we have a pair of 3s. And a pair of numbers, or a number times itself, is a perfect square. So that 3 times 3 can come out. And so that's going to be 3, because the square root of 9 is 3. And then that 5 stays inside. So any pairs come out, and then anything that's not a pair stays inside. If more than one pair comes out, it multiplies and stays out. If more than one thing stays inside, it multiplies and stays inside. All right, let's try 24. So different ways you can start: 8 times 3, 6 times 4. It doesn't matter because we still do the factor tree, and the factor tree still comes out the same. So when we break it down, we end up with 2 times 2 times 2 times 3. So a pair of 2's can come out as a 2, because 2 times 2 is 4, and the square root of 2 is 2. And then this 2 times 3, these 2 stay inside. 2 times 3 is 6. As you can see, we are going to get a lot of practice here because this is something new. So we break it down into its prime factorization. The pair of 2's comes out as 2, and the 5 stays inside. Now, at any time, you can pause this and try some of these on your own and then tune back in and check. So 63 is 9 times 7. And you can see we have a pair of 3's. So the 3 comes out, the 7 stays inside. 75. That is 25 times 3, 5 times 5. So the 5 comes out, the 3 stays inside. With the 40, most of you probably think 4 times 10, 2 times 2, 2 times 5. So here we have the pair of 2's comes out, 2 times 5, or 10, stays inside. Ooh, here's a big one, 108. I might need my calculator for this one. Let's see, I know it's even, right? So I can always do like 108 divided by 2 to make it a little bit smaller. So 2 times 54, and 54 is 6 times 9, 3 times 3, 2 times 3. So looks like we have a pair of 2's comes out. So 2 comes out, pair of 3's come out, and this 3 is left inside. So that's going to be 2 times 3 or 6, square root of 3. Now these last ones, multiplying square roots. When you multiply square roots, you multiply anything that's outside the square roots together, and then you multiply anything that's inside square roots together. So this turns into the square root of 18, 3 times 6. And so now we simplify it. 9 times 2, 3 times 3. So looks like this is going to be 3 square root of 2. This is going to be 6 times 10, the square root of 60. Now we can break it up just the way it was, 6 times 10. However you break it up, doesn't matter. We end up with the same numbers at the end. Pair of 2's comes out, so 2 comes out. 3 times 5 stays inside, so that's that. Finally, again, you multiply outside parts together. So 2 times 5 is 10. 3 times 15, 45. And so now we simplify the 45, so that's 9 times 5, 3 times 3. So that 3 comes out. Well, guess what? When that 3 comes out, it's going to multiply with the 10. And so that's going to be 30 square root of 5 is our final answer. That 5 stayed inside.